in update, create a constant variable called bob x coordinates and assign it bob's x coordinate. Game state.player.x. So we'll go ahead and do that down here. Scroll down and add the code in here. And let's see, so Bob, create a constant variable Bob x coordinate. All right, do that in just a moment. Let me check to see if everything is going well with the stream. Got a one monitor set up here, so I'm gonna check on my phone. I'm gonna see if everything is going right. We're still live. All right, looking good. Looking good. Okay, looks like it restarted itself, but that's interesting. So it just kind of segmented the stream. So I'm glad I paused, because now you'll be able to see the other part of it. All right, so add variables to the update function. So we're going to do a constant variable, call it Bob x coordinate, and assign it Bob's x coordinate. So game state dot player dot x. And for now, we don't know exactly what this is doing, like what game state is, where it is. We could look at that through, you know, this code, but for now, we don't need to know that this is accessing an object, kind of like a global object that contains all of the properties, or most of the properties of the game, and what the update function, the create function, is referencing for coordinates and movement and all this. All right, so below, yep, so we did that part. Just as game state player gets Bob's x coordinate, game state.player.y gets Bob's y coordinate. Create a constant variable called Bob y coordinate and assign it to Bob's y coordinate. Okay, so same thing that we did, except we're changing this to y. We'll go ahead and just copy this bit and then change the x to a y and this x to a y. With those two constants, we can now check if Bob has touched the left or the right walls of the game. The left wall is located at 32 from the left, and the right wall is located at 448 pixels from the right, or from the left. Okay. On a new line below your previous code, write an if statement that checks if Bob's x coordinate is less than or equal to 32, or if Bob's x coordinate is greater than or equal to 448. Leave the inside of the if statement blank for now. So, check the collision between him. Okay, so we're just going to do this down here. So to start with an if, we're going to check to see if the x coordinate is less than or equal to 32. So Bob x coord. So less than or equal to. I forget the order of this, if it's, you have to put the less than or the equal to first, but we'll find out. So this to 32, and then put our two pipes in, and put Bob y coordinate is greater than or equal to, and I think you put, or no, you don't put the equals first, you put the greater than symbol first. Because if you put the equals first, it's going to read it differently. We haven't gotten to arrow functions yet, but it reads it like you're trying to start an arrow function, I believe. So do 448. So this is checking to see, we put an or statement in there. So like, or if this is true or this is true, run this code. So leave it blank for now. Add another if statement under the code that you wrote. That checks to see if Bob is touching the top and the bottom walls by using the y coordinate. The top wall is located 32 pixels from the top, and the bottom wall is 568 pixels from the top of the game screen. In this conditional, check to see if the y coordinate is less than or equal to 32 or greater than or equal to 568. Okay, so what I didn't do correctly here, the Bob x coordinate is all that we're checking here. So we want to see that it's either less than 32 or greater than 448. I thought we were checking the y and the x, but this is just for the x coordinates. underneath this, we'll do another one that checks for the y coordinates. So Bob y, and this is less than or equal to 32. So that one's the same. We'll put in our two pipes, and then Bob y coordinate is greater than or equal to, and it was 568. Alrighty. Let's put that in. Oh, I got double. Let's get rid of those curly braces we don't need. If Bob touches a wall, we want to end the game. Inside each of the if statements we just created, call the end game method inside each of the statements by adding the code this.endGame. Before you move on, check your work by touching each of the walls, making sure that the game over screen is displayed if Bob touches a wall. All right, so simply this.endGame. End is lowercase, then game is camel case. Doing this. This.endGame, we'll also copy this into the y coordinate. And then we'll see if when Bob touches a wall. Go ahead and save, Control Enter. All right, Bob. See if, whoa. Whoa. Look at that. All right, so something's off, right? Something's off. I'm guessing it's the operators. If I messed up the operators. So less than or equal to 32. So yeah, he just kind of, when it pops in, right? It pops in, he immediately loses, yeah? So let's play around with this. Let's say that instead of that, it's going to be like this, right? So the less than symbol goes in front of the equal sign. Let's go ahead and save that code first of all. Because if you don't save it, it'll just run off of what it was doing earlier. Okay, so this is a good important note that if there is an error when you're doing one of the projects on CodeCademy, it won't actually display that there's an error. It'll just give you a completely blank canvas, white screen. The game will not display at all. The start screen will not display at all. It'll just, yeah, be completely white. And that says that something in the code is off. There is a syntax error somewhere. So let's switch this back. So maybe it wasn't. Okay, so it likes that better. It likes, I think we have this operator correct. But yet he still loses. Ah, I see. Okay. So this was set to a less than. So basically it was saying if the y coordinate is anything less than 568 and the game, which it was at the beginning of the game, and voila. So we just changed that little less than to a greater than symbol, and now we are good to go. Let's see. So with Bob, let's see if he touches the wall, does he lose? He does indeed. And just to be thorough, we're gonna test every single wall. Test that wall and test the top, test the ceiling of the world. There we go. So Bob does lose if he touches the walls. Okay. All right, our game is almost done. However, you may have noticed a problem if you played the game a few times. Hey, thank you for the follow. I appreciate it. Bob's earnings do not reset to 0 in the new games. Yeah, we noticed that earlier, that the score, if you play it once, the score doesn't reset. So you get 700 points, you lose, and then you try to play it again, and then you still have $700. Business snake, yes, exactly. Okay, so in the end scene file of the create method, reset the score variable to 0. Okay, so we want to navigate to the end scene file. End scene to reset the score variable to 0. So this is within here, okay. To reset global variable. So we want, after the end screen displays, we want the score to reset itself back to 0. And I think you can just do it like that, just declaring the variable or referencing the variable. Okay, going further. That's it. Okay, let's see if that worked. Press any key to restart. We got to save this part and then test to see if the score does indeed reset. Yes, it does. Okay, simple as that. So then after the end scene sets the score back to 0, when the game scene starts, it is at 0. Sweet. All right, that's it. You've successfully finished essential features of a phaser game using JavaScript. Great work. If you finish the game and are curious about the JavaScript library we use to make Business Outfitted Bob Phaser, you can take a look at the Phaser cheat sheet here. This will make very little sense to us now, but they build the foundation of it later. So if you want to challenge yourself, see what additional changes and features you can add to the game. For example, try the following. Change the speed Bob moves. Bob should move faster as he collects more money and his earnings increase. Add code to the game scene so that when Bob and the money sprite overlap, speed will increment by 1. What changes would you have to make when declaring the speed variable to make this work? Interesting. Okay. So I remember where this was set. Constant speed 1. So we want to move him faster as his earnings increase. I'll let the speed will increment by 1. Okay. Oh, cool. Oh, well, thank you. Thank you for tuning in. I myself am learning, so this will be educational for both of us. All right, so let's see if we can puzzle this out here. So we want the speed to increment as he accrues more money. It's right in the overlap and the speed. I don't know, let's see. Bob and the money sprite overlap, speed will increment by 1. I don't know how to check to see if the sprites overlap. What changes would you make when declaring the speed variable to make this work? Okay, so let's talk through the theory of this, because I don't know if I know enough to actually complete it. But so basically, there would be a conditional to check, see if the sprites are like at the same coordinates, and then the speed variable inside of that conditional would increment by 1. I can see this working with a loop function, but we haven't gotten to those yet. And I don't remember the syntax for that. Let's see if the hint helps us a bit. We can add code to increase the speed inside of the create after this physics.add.overlap gamestate.player gamestate.money. Okay. Probably would not have found that on my own. Since we will be changing the value of speed, we will have to change it from a constant to another type of variable that can... Oh, yes, that's right. So first of all, we have to change this to let, right? Let speed equal 1. And also, I kind of want to just play around with this. See, what's speed 7? What does that do? Whoa! Yes. Oh, yes. Okay. Let's go back to 1. Okay, so this .physics.add, so let's see where that is. Score text, this .physics.setBounds, add overlap. You can add code after the add overlap. Oh, there's already an overlap function. Okay, that's helpful. So it's this one to increase the speed inside of that. So this is where gamestate.money disabled body. Okay, this is what I'm guessing. This is what makes the money disappear after you overlap with it, and then move the money somewhere else on the canvas. Okay. Oh, the comments tell you what it's doing. Yeah. Okay. So that hides the money and deactivates the sprite in that location. Random coordinates, assign coordinates. Score plus money multiplier. Okay, so maybe down here we can do it. Let's see. At the moment, I'm just learning JavaScript. I guess this would be, it's eventually going to be entirely from scratch, but I think that would still be front-end developing. I don't know. I don't know enough to tell you. But right now I'm just learning JavaScript and Phaser. Okay, so we need something like this where there's an increment, right? So plus equals. Okay, so let's just add one down here, right? So I think if you just do speed, once it overlaps inside of that function, we just do a speed plus equals 0.01 or 0.1. I think that should be enough, right? So it increments this and affects the speed variable. Let's see if that works. I don't know if we'll be able to tell because it's such a slight change. But we shall see as we play the game. Okay, yeah, he does get a little bit faster. So that was actually super simple. We just needed to find where the overlap was being referenced and then do an increment of 0.1. Cool. Yeah, this is the more complicated bit, like understanding the this keyword, game state, the game state object, and then how the different properties work. That comes later, but once that's built, then it's super simple to increment something, even without a loop function. You can just say, whenever this happens, then speed is incremented by 0.1. Let's try to make the difficulty a little bit harder, 0.2 maybe. Let's save this code. And now, since we're at the end of the game, let's see. I'll play it a couple times, see if I can get a high score. I don't know. Let's see, 700. Oh. So that was 1400. I think later they show you how to do like high scores. Oh, yeah, it's tricky. The paper just, I wonder if there's a way to, I mean, I'm sure there is a way, but I don't know how to do it. Like if the paper appears, have it appear at least one square away from Bob. Okay, 2500 so far. Oh no, the speed isn't resetting. Guess what? Wait. Okay, so what we did with the score, we have to do with speed, or else it'll just keep getting faster and faster. So we go back into the end scene file, and just like we did with the score, we put speed equals 0. And now when we start it, or when we restart it after he loses, he should go back to being slow Bob. Slow Bob like he is. There we go. Okay. All right. Oh man. All right, what was that? 30, 35? Oh no. Oh no. All right, so I set speed to 0 instead of 1. We need him to actually be able to move at first. In that iteration, he hit a wall and then couldn't. He was paralyzed. Let's try this again. Okay, avoid the paper. No. All right, let's play this a couple more times. Now that we've got it working, I'm gonna see if I can get like, I don't know, 4,000. That's probably gonna be a challenge. Let's see if we can get that. Business Bob. Yeah. No. Almost. One more time. But yeah, you know, this is one of the great things about game creation, is that you can test your product and have fun with it immediately after you code it. All right, one more. There, success. Okay. All right. Let's reset that. All right, so that is Business Outfitted Bob. Let's see, so front end, from the chat, front end is all the looks and the site of the game, what back end is making everything actually work. Yeah, that's my general understanding of it too. Like, yeah, kind of like website design, as far as the aesthetics of the website, and maybe like the navigation of the website is front end, but then how the boxes are actually displayed or what size they are, that might be back end. I'm not sure. But yeah, that's my general understanding. All right, that is Business Outfitted Bob. Let's see if we ticked all those boxes. Looks good. So at the end of these, they actually give you informationals, the solutions to whatever project you were working on. And they also tell you that there's not just one solution to complete the project. If the code looks different, but it still works, hey, it still works, right? And you found an alternative solution than they had. A lot of the times, if you look at these, their code's going to be a little bit more like elegant, a little bit more advanced. But if you can get it to work, that's the important thing at this point in time. All right. Oh, CodeCademy is going to ask me how I like this. Yes, I am very satisfied with this course. Anything we can do to improve? Just keep on keeping on. Okay. Submit. Thanks, CodeCademy. All right. So the next section will be about functions, and we'll dive into this. I don't know if we will complete it today, but we'll see how far we can get. It's kind of short, so we might be able to do the whole thing. Start next lesson within hour 15, yeah. What are functions? Let's see. Got a little graphic on the side there. When first learning how to calculate the area of a rectangle, there's a sequence of steps to calculate the correct answer. Measure the width of the rectangle, measure the height of the rectangle, and multiply the width and height of the rectangle. With practice, you can calculate the area of the rectangle without being instructed with these 3 steps every time. Okay, so we can calculate the area of the rectangle with the following code. Declare a width variable, declare a height variable, and then say that width times height equals area, and console log the area. Imagine being asked to calculate the area of 3 different rectangles. You'd have to repeat the code 3 times. In programming, we often use code to perform a specific task multiple times. Instead of rewriting the same code, we can group a block of code together and associate it with one task. Then we can reuse the block of code whenever we need to perform that task again. We achieve this by creating what's called a function. A function is a reusable block of code that groups together a sequence of statements to perform a specific task. In this lesson, you will learn how to create and use functions and how they can be used to create clearer and more concise code. Okay, take a look at the provided GIF. It shows a function named add1side, adding an additional side to the different shape inputs. Notice how there is only one function represented by the box that is used to transform the individual shapes to the new shapes. Okay, so they've got the function labeled as add1side. And no matter how many sides the shape has as it goes through, passes through the function, it then has an additional side. Okay. Function declarations. In JavaScript, there are many ways to create a function. One way to create a function is by using a function declaration. Just like how a variable declaration binds a value to a variable name, a function declaration binds a function name to an identifier. Take a look at the anatomy of a function declaration below. So you've got the function keyword, which is simply literally just function, the identifier, greet world. So this is basically what you are calling that specific function, and then the code inside of it. A function declaration consists of, as I said, the function keyword, the name of the function, and a function body. A function declaration is a function that is bound to an identifier. In the next exercise, we will go over how to run the code inside the function body. We should also be aware of the hoisting feature in JavaScript, which allows access to function declarations before they're defined. Take a look at an example of hoisting. Greet world. So this outputs hello world, and the function is declared underneath. So you can actually call a function earlier in the code than it's actually declared. So notice how hoisting the greet world to be called before the greet world function was defined. Hoisting isn't considered a good practice. We simply want you to be aware of this feature. So just in case you want to be a little crazy with your code, just go ahead and hoist your functions. If you want to read, but yeah, I mean, the general practice, it's like less confusing. Unless you have it in sort of a list of parameters within an object, hoisting might be better so that you can see like your objects are at the top of the console and easily viewable. But besides that example, it's better to just put your calls to the functions below it. So let's create a function that prints a reminder to the console. Using a function declaration, create a function called getReminder. All right. Oh, thank you so much. Thank you for the well wishes. You as well. All the best. Let's create a function that prints a reminder to the console. Using a function declaration, create a function called getReminder. All right. Function getReminder. And let's see if we run that. In the function body of the getReminder, log the following reminder to the console. Water the plants. So console.log, we want to add in a string here of water the plants. Okay, run that. Let's create another function that prints a useful Spanish travel phrase to the console. Using a function declaration, create a function called greet in Spanish. Okay. So we'll add another function down here. Just type in function and greet in Spanish. Remember to put those parentheses after whatever you're naming your function. All right, let's check that. Add code to the function body of greet in Spanish. In the function body, console log the following Spanish phrase, buenas tardes. Okay, console log, and then we'll want a string, buenas tardes, good afternoon. And check that. Okay, cool, looks good. Calling a function. As we saw in previous exercises, a function declaration binds a function to an identifier. However, a function declaration does not ask the code inside the function to run. It just declares the existence of the function. The code inside a function body runs or executes only when the function is called. To call a function in your code, you type the function name by name followed by parentheses. So the identifier, essentially. This function call executes the function body, or all of the statements between the curly braces in the function declaration. We can call the same function as many times as needed. So basically you declare a function, then you call it. This function call says, okay, now go ahead and run what's inside of this function declaration. And yeah, so then the code will run after the function call. So when you declare functions, it's not saying that code will run it immediately. You have to call it. This is basically setting up the phone number, and then this is calling the phone number. Okay, so imagine that you manage an online store. When a customer places an order, you send them a thank you note. Let's create a function to complete this task. Define a function called sayThanks as a function declaration. In the function body of sayThanks, add code such that the function writes the following thank you message to the console when called. Thank you for your purchase. We appreciate your business. Okay, so as we did before in the previous exercise, first declare it. So sayThanks. sayThanks. Add in those lovely parentheses. Inside of this, we're going to console log a string, and I'm just going to go ahead and copy all of this down instead of typing it. Save a second or two. Whoa! Whoops! I copied the quotations as well. Let's add that in on either side. There we go. All right, thank you for your purchase. We appreciate your business. All right, let's check that. Sweet. Now, as you can see, even though we have a console log in here, it didn't do anything. It did not log to the console. That's because we must call the function. So let's call the function, and you simply do that by sayThanks and this parentheses. And this is equivalent to the way that variables work, where you are, well, not equivalent, of course, because they're different data types, but the structure of it is symmetrical. So you declare a variable with the let or the constant, and then you can, oh, I had sassy thanks. Yeah, sassy thanks. Oh yeah, so then you can reference that variable by using the name that you created for it, just like here where you can reference the function or call the function by just putting in the name that you gave it. All right, so say thanks, and now since we called the function, then it runs the code inside of that, and console logs, thank you for your purchase, we appreciate your business. Functions can be called as many times as you need them. Imagine that 3 customers placed an order and you wanted to send each of them a thank you message. Update your code to call say thanks 3 times. Okay. So just like this 3 times, yeah. So down here, 1, 2. Thanks. Thank you so much. Parameters and arguments. So far, the functions we've created execute a task without an input. However, some functions can take inputs and use the inputs to perform a task. When declaring a function, we can specify its parameters. Parameters allow functions to accept inputs and perform a task using the inputs. We use parameters as placeholders for information that will be passed to the function when it is called. Let's observe how to specify parameters in our function declaration. Function, calculate area, parameters. Okay, so yeah, these go within the parentheses, console log, and then you console log the parameters, treated like variables within a function, okay? And so, as we're seeing with this, and you'll see with a lot of other examples in the future, you can basically like stack different data types, right? So you can have functions and variables, or objects and properties and functions and variables and parameters and et cetera, et cetera, et cetera. So in this case, we have a function. Inside of the function, we have parameters that we are declaring. So that word declaring like references back. It's kind of like variables, but variables that we can use within the function, not global variables, ones that we can use anywhere along our block of code. It's just within that function, those parameters are set like variables. In the diagram above, calculate area computes the area of a rectangle based on 2 inputs, width and height. The parameters are specified between the parentheses, such as width and height, and inside the function body, they act just like regular variables. Width and height act as placeholders for the values that will be multiplied together. When calling a function that has parameters, we specify the values in the parentheses that follow the function name. The values that are passed to the function when it is called are called arguments. Arguments can be passed to the function as values or variables. All right, so not to muddy the waters, but with an identifier, arguments as values. So in the function call above, the number 10 is passed as the width and 6 is passed as the height. Notice that the order in which arguments are passed and assigned follows the order that the parameters are declared. So when you first declare a function, within these parameters, or I should say these values within the function declaration are called parameters. When they are referenced or when they are called with an identifier, then they are called arguments. So you declare a function with parameters, and then you call a function with arguments. In the function call above, the number 10, yes, I read that already. Notice that the order in which the arguments are passed, I read that already as well. Okay, so we have constant rectangle width equals 10, constant rectangle height equals 6. Then it calculates this based off of the function that was created before. So rectangle width and rectangle height. This is a little different because it's not setting the variables within a function. It's setting, it's using the arguments from variables that were already declared globally. The variables rectangle width and rectangle height are initialized with the values for the height and width of a rectangle before being used in the function call. By using parameters, calculate area can be reused to compute the area of any rectangle. Functions are a powerful tool in computer programming, so let's practice creating and calling functions with parameters. The sayThanks function works well, but let's add the customer's name in a message. Add a parameter called name to the function declaration for sayThanks. Okay, so in here, it'll be within the parentheses and add name. And let's see if that is what we do. It is. With name as a parameter, it can be used as a variable in the function body of sayThanks. Using name and string concatenation, change the thank you message to the following. So now this is a function specific variable. That's what I'll call it. Thank you for your purchase. We want to add in a quotation mark there to put the name before the exclamation point. This is going to be plus name plus, and then we do the opening quotations there to add the rest of the sentence. Copy and paste the message into your code. I don't really need to copy and paste it, but they might be specific about the spacing, so we'll go ahead and do that. What? Let's see. Oh, there needs to be a space. They're being very picky. There needs to be a space here as well. Yeah, and then not a space here. There we go. Okay. CodeCademy's happy. A customer named Cole just purchased something from your online store. Call sayThanks and pass Cole as an argument. Okay, so this is where the magic happens. It might have sounded a bit confusing before, but you'll be able to see it all together, see the both ideas together. So we do sayThanks, right, to call the function. Inside of these parentheses, we type in the name that we want. So we want it to be Cole, right? And so what this is doing is that it says, okay, so this is now an argument that's going to be passed through this function. So then when it looks at this, it says, okay, so the argument that's there is name. So wherever name is within the function, that's going to be replaced by what was passed through it, which was the word Cole. And we also want this to be in quotes, right? Because it's not a variable, it's a string. So now if we run it, voila. Thank you for your purchase, Cole. We appreciate your business. Great. Yeah, and then you can put any name in here. You can put Naomi or Jackson or whatever name you want, whatever name you're feeling. Thank you for the follow. Appreciate it. Welcome to the stream. And that way, yeah, you use an argument to pass through a parameter to be used as a variable within the function. A lot of vocab, but when you see it all together, it's a lot easier to understand. Why am I learning programming? It's actually a lot of fun. Yeah, it's I've thought about learning it for a long time. I didn't go to college for it, but I kind of was on the outskirts of doing a little bit of coding during college, and I just thought, yeah, maybe try to pick it up. I saw that CodeCademy had a course, had several courses on this, but end goal, right? End goal would be perhaps making a video game. I have a few ideas in mind, and I want to learn sort of at least a general understanding of, you know, the back end of doing it, creating the code for it, and then mostly what my expertise is in is actually designing elements for video games, like using Blender and things like that. But I'd rather learn how to do the coding at this point in time. But anyway, thank you for the question. Thank you for the follow. Default parameters. One of the features added in ES6 is the ability to use default parameters. Default parameters allow parameters to have a predetermined value in case there is no argument passed into the function or if the argument is undefined when called. Take a look at the code snippet below that uses a default parameter. Function greeting. Name equals stranger. Console log hello name. Greeting Nick. So this is doing what we did before, passing an argument through the parameter. So the output would then become that argument with the message hello Nick. And then if you don't pass an argument, it would just be hello strangers. In the example above, we use the equals operator to assign the parameter a default value of stranger. This is useful to have in case we ever want to include a non-personalized default greeting. When the code calls greeting Nick, the value of the argument is passed in, and Nick will override the default parameter of stranger to log hello Nick to the console. When there isn't an argument passed into greeting, the default value of stranger is used, and hello stranger is logged to the console. Okay, pretty self-explanatory based off of what we did in the last exercise. So this is simply stating that the parameter does have a default value. This is kind of like the else of the function. It's like, okay, so if nothing is put in as the call, this is the default, right? Much like the default in the switch code blocks. All right, so let's practice creating functions that use default parameters. The function make shopping list creates a shopping list based on the items that are passed to the function as arguments. Imagine that you always purchase milk, bread, and eggs every time you go shopping for groceries. To make creating a grocery list easier, let's assign default values to the parameters in make shopping list. Okay, so change the parameters to default parameters. So milk, bread, and eggs. So we want item 1 to equal milk, item 2 to equal bread, and item 3 to equal eggs. Send a default value of milk to item 1. Let's see, what syntax am I missing here? Oh yeah, see, I didn't add the quotation marks. So those were trying to be read as variables, and they could not be because they don't exist as variables. So make sure to put in those quotation marks to create strings as your defaults if you're going to put it into a message. Let's try that again. Okay. Easy as pie. Return. When a function is called, the computer will run through the function's code and evaluate the result of calling the function. By default, that resulting value is undefined. Function rectangle area width and height. Let area equals width times height. Console log rectangle area 5, 7 prints undefined. So before reading their explanation, because sometimes that can be so detailed that it's like a little bit overwhelming, let's just look at what the code they have here and see if we can puzzle out what it's doing. So it's calling the function within a console log. So basically whatever is inside of here, whatever calculation is being done, it'll console log the result. And then it's putting in arguments of 5 and 7 for the parameters of width and height. So then that will add, or rather multiply 5 by 7 and assign that to the variable area. Okay, so let's see. But when we went to print the results from this, we got undefined. So there was a problem with our code. Did we write our function wrong? No. In fact, the function worked fine, and the computer did calculate the area as 35, but we didn't capture it. So how can we do that? With the keyword return. So running this code doesn't actually do anything. It just prints undefined. Because when you console log this, it's trying to see inside of the function, but nothing's really happening. It calculates it, but then it doesn't return the value in order to console log. So we need a return and then of the variable. So basically the variable is assigned here as 35, but then nothing happens with it. It just stays in the function. It doesn't go anywhere. So return area. To pass back information from the function call, we use a return statement. To create a return statement, we use the return keyword followed by the value that we wish to return. Like we saw above, if the value is omitted, undefined is returned instead. Is this my first time learning this stuff? I've learned part of this course before, but I reset my progress in order to stream it all. It also had been a month or two since I looked at it, so I forgot most of it. But yeah, I did go through about 70% of this course. And I'm working my way back up, building the knowledge back up. So when a return statement is used in a function body, the execution of the function is stopped and the code that follows it will not be executed. Look at the example below. Okay, Well, thank you. I appreciate that. If the width is less than 0 or the height is less than 0, return you need positive integers to calculate area. Return the width times height. So if an argument for width or height is less than 0, then the rectangular area will return that message. The second return statement will not run. So once you put in a conditional with a return statement, if that does if it does meet the evaluation of the conditional, then it will end the code with the return and it won't go on. Much like it is with like we saw last time with the switch keyword, with the different breaks. So it'll run the case. If the case is true, then it will run the code. And if there's a break line, then it will stop and not evaluate the rest of the code block. Much like it's happening here with return, the return keyword. So the return keyword is powerful because it allows functions to produce an output. We can then save the output to a variable for later use. Okay. Imagine if we need to order monitors for everyone in an office, and this office is conveniently arranged in a grid shape. We could use a function to help us calculate the number of monitors needed. Declare a function monitor count that has two parameters. The first parameter is rows, and the second parameter is columns. Okay? So say function monitor count, and then two parameters of rows. Remember to separate your parameters with commas, and also remember that the order matters for arguments later. Let's compute the number of monitors by multiplying rows and columns and then returning the value. In the function body of the function you just wrote, use the return keyword rows and columns. Okay, so return, and then I don't think you need anything before you just reference the variables and columns. Let's see if that's correct. We might need something else. Okay, that is correct. Now that the function is defined, we can compute the number of monitors needed. Let's say that the office has 5 rows and 4 columns. Declare a variable named number of monitors using the constant keyword, and assign number of monitors the value of invoking monitor count with arguments 5 and 4. Okay, this can be a little bit in the weeds. At least it feels that way, but it's actually rather simple. So we need to declare a variable first. Let's take it step by step. So we declare a variable constant number of monitors. Okay, and then assign it, so user equal sign, by invoking the monitor count. Invoking is another word for calling, so we'll put in our monitor count. Inside of this, we're going to put the arguments 5, 4 to refer back to the rows and columns. Okay, so we have a variable that calls the function. And now to check that the function worked properly, log number of monitors to the console. So now console log, and now we console log the variable that's containing that calculation. So just number of monitors, 20. Voila. And now if we change these values, if we say that the columns are 16, right, then it will change the value of the calculation. So yeah, that's the way to work with the return keyword. And since that's there, now when the calculation is made, something is actually taken out of the function and then given to the console log so that it can print it. All right, helper functions. We can also use the return value of a function inside of another function. These functions, being called with another function, are referred to as helper functions. Since each function is carrying out a specific task, it makes our code easier to read and debug if necessary. If we wanted to define a function that converts the temperature from Celsius to Fahrenheit, we could write two functions like this. So let's see what they have here. So they have two functions, simply calculating Fahrenheit. In the example above, the get Fahrenheit is called and 15 is passed as an argument. The code inside of get Fahrenheit calls multiply by 9/5 and passes 15 as an argument. So yeah, so these are linked. with their returns. So the get Fahrenheit function returns multiplied by 9/5, which is a function with the argument of Celsius. So that Celsius is then passed through the parameter of number. And then as this is called, it's also adding 32. So then it returns that number parameter, which is using the Celsius argument, and then multiplying it by 9/5. So then what happens is we get Fahrenheit. We're calling this function and using the argument of 15. That argument is passed through Celsius, which is passed through here, which is passed through here. This is multiplied by 9/5, and then 32 is added to that number. So you can chain several functions on top of each other and have them link back. This is especially useful, but also sometimes you'll find yourself like digging through the code and like, okay, this reference is back here, and it's kind of like following a family tree, right, all the way back up to your oldest ancestor. In the example above, so we have code block, just scanning this to see if it said anything else that I didn't say. Looks good. It's just going through the math specifically. Okay, so we can use functions to section off small bits of logic or tasks, then use them when we need to. Writing helper functions can help take large and difficult tasks and break them into smaller or more manageable tasks. So in the previous exercise, we created a function to find the number of monitors to order for an office. Now let's write another function that uses monitor count to figure out the price. Below monitor count, create a function declaration named cost of monitors that has two parameters. The first parameter is rows and the second parameter is columns. Leave the function body empty for now. All right, easy enough. Let us declare a new function, call it cost of monitors. Cost of monitors, add in here rows and columns, so same parameters as before, and make sure to have it in that order. Although in this case it doesn't really matter because it's just doing like a simple multiplication, but just get into the habit of ordering your parameters properly. Okay, just leave that empty. Time to add some code to the function body of cost of monitors to calculate the total cost. Add a return statement that returns the value of calling monitor count rows and columns multiplied by 200. Okay, so let's do return. And we are going to call our previous function, monitor count. And they're not adding any values to the rows, they're just passing the same arguments back through. And then this is multiplied by 200. Okay, and we should save the cost to a variable. So declare a variable named total cost using the constant keyword. Add total cost to the value of calling cost of monitors with the arguments of 5 and 4. Okay, so this is where we're actually passing through some values instead of just having the parameters be empty. So we want a variable of total cost. We can put that as constant. So total cost, and just have that equal to the cost of monitors. And so this is calling the second function that we have and then passing through the arguments of 5 and 4. And so 5 and 4 will be passed through these parameters, which is going to be in this calculation. That's then passed through these parameters. So then the rows are going to be multiplied by the columns. And then this, which is the price, the price multiplier, will then multiply by the rows and columns together. Of course, it doesn't matter which order you do that in, but just that's the logic of it. To check that the function worked properly, log total cost to the console. Okay, so lastly, let's console log. The order of operations, of course, would matter if it was, you know, adding or subtracting, but we're all multiplying, it would be the same either way. So we're just going to console log total cost. And the total cost of the monitors will be 4,000 for 20 monitors. So this is one of the beautiful things about coding like this is like as you're going, you're I don't know how to describe it. It's like your calling or console logging becomes simpler and simpler as you go. Like the code becomes, it's funneled down to one command. It's like, okay, now run total cost, and then the rest of it runs, right? So a lot of the times with coding, we're building the outset of the funnel and then tapering it down until it's just like one command, console log, total cost, 4,000, booyah, let's go to the next exercise. Function expressions. Another way to define a function is to use a function expression. To define a function inside an expression, we can use the function keyword. In a function expression, the function name is usually omitted. A function with no name is called an anonymous function. A function expression is often stored in a variable in order to refer to it. So consider the following. So within a variable, we can declare a function. So we have our variable, then we declare a function with parameters, and then everything else is the same below that we learned before. To declare a function expression, declare a variable, make sure the variable's name, or make the variable's name be the name or identifier of your function. So it's basically, it's kind of doing it in reverse. But so the identifier, instead of being after the word function, it's going to be before, and it's going to look like a variable. Okay, assign that variable's value an anonymous function created by using the function keyword followed by a set of parentheses, and then with possible parameters. Then set a set of curly braces that contain the function body. To invoke a function expression, write the name of the variable in which the function is stored, followed by parentheses enclosing any arguments being passed to the function. So variable name, argument 1, argument 2. Unlike function declarations, function expressions are not hoisted, so they cannot be called before they are defined. Let's define a new function by using a function expression. Of course, they told us before that hoisting is not good practice anyway, so you can pretty much ignore what this means. But yeah, function expressions, if you're using it within a variable, they're not hoisted. But let's define a new function using function expressions. All right, so let's say we have a plant that we need to water once a week on Wednesdays. We can define a function expression to help us check the day of the week and if the plant needs to be watered. Create a variable named plant needs water using the constant variable keyword. All right, so let's do constant and plant needs water. Speaking of which, I'm going to take a drink of water. All right, assign an anonymous function that takes in a parameter of day to plant needs water. So function, and the parameter will be day. And in this, we can add our curly braces and check to see if that is all shipshape. Good. Okay, so now we need to add some code to the function body of plant needs water. In the function body, add an if conditional that checks day if day is equal to Wednesday. If the conditional is truthy inside the if code block, use the return keyword to return true. Okay, so if these are if keyword, we put in our parentheses, we say day is equal to Wednesday, Wednesday, and this has to be a string. Yeah, day doesn't have to be a string because day is the parameter that we set, so it is a variable within a function. But Wednesday does need to be in a string. If the conditional is truthy, inside the if code block, use the return. Okay, so add our curly braces and then put a return to return true. So then this true, what that does is that it basically says that this variable is true and the plant does need water. And then we'll be able to log that in the next couple steps. On days that aren't Wednesday, plant needs water should return false. So add an else statement after the if statement, and then use the return keyword. So we're going to put in else, and then so this will be any day other than Wednesday. If the day equals anything else, even if the day equals a number, this code will run instead, and we will return false. Okay, check that. All right, call the plant needs water and pass in Tuesday as an argument. Okay, so we're going to have this below our function. We're going to call the function of plant needs water. Plant needs water and pass in Tuesday. Now Tuesday needs to be a string. And there we go. So what happened was this Tuesday was passed into the day parameter. This conditional ran. It saw that it wasn't Wednesday, so it skipped this step. It went to else and returned false. And so it sees that it is not Wednesday, so therefore the plant does not need water. Of course, we didn't see anything in the console. Nothing was logged to the console because we haven't told it to do that yet. But that's what's happening behind the scenes in the black box of the code block. So let's check that plant needs water, returned the expected value. So log the plant needs water Tuesday to the console. So now, instead of doing this in a second step, what we can do is just add the console log, right, here, and then have the function call be contained within the console log. So then it will print out false. So whenever you're testing out a function and you want to see it, you can do it like this, where you console log whatever function, whatever function you're calling. All right, arrow functions. ES6 introduced arrow function syntax. There's a shorthand way to write functions by using the special fat arrow notation. Arrow functions remove the need to type out the keyword function every time you need to create a function. Instead, you first include the parameters inside the parentheses, and then add an arrow that points to the function body surrounded by the curly braces. So essentially, if you're doing it as a function expression, so you declare a variable, then you don't need the word function. You just put parentheses, add your parameters, and then this equal sign, greater than symbol, curly braces. They call this a fat arrow. Don't want your arrows to be skinny. You want some fat arrows. Change plant needs water to use arrow function syntax. All right, so we're going to refactor or edit this code into arrow function syntax. So delete function, and then add in that fat arrow, and that should be all we need. Yes, indeed. And so that's just a shorthand way of declaring a function. All right, so concise body arrow functions. JavaScript also provides several ways to refactor arrow function syntax. The most condensed form of the function is known as a concise body. We'll explore a few of these techniques below. Functions that take only a single parameter do not need that parameter to be enclosed in parentheses. However, if a function takes 0 or multiple parameters, parentheses are required. Interesting. So if the function doesn't take any parameters, parentheses are required. Okay, so with 0 parameters, you leave it as an empty set of parentheses. With 1 parameter, you just state, or you just declare your parameter without parentheses. But with 2 or more, then you add the parentheses and then add that comma in between. So a function body composed of a single line block does not need curly braces. Without the curly braces, whatever that line evaluates will be automatically returned. If the contents of the block should immediately follow the arrow, or the contents of the block should immediately follow the arrow, and the return keyword can be removed. This is referred to as implicit return. Okay, so basically the shortest way of doing this is in a single line block. If it's the simplest function possible, it'd be constant. You declare your variable or declare the function name equals, declare your parameter, fat arrow, and then whatever you want to happen with that parameter. In a multi-line block, then you need to add in the curly braces, just like we were doing before. And then add in what you want to happen with the variable, and then return that variable. With a single line block, if it's just literally just one line of code, then you don't need the curly braces and you don't need the return. So if we have a function, we can refactor the function to this. So basically just condensing like a couple lines into one and eliminating the curly braces. So the parentheses around num have been removed since it's a single parameter. So that was this one. The curly braces have been removed since the function consists of a single line block. And the return keyword has been removed since the function consists of a single line block. So let's refactor plant needs water to be a concise body. So let's see. So delete the return, delete the curly braces, bring this back up to one line, and then also remove these parentheses around the parameter. And that should be all we need. Review functions. Give yourself a pat on the back. Well done. You made it to the end of the function introduction. Give yourself a pat on the back. You just navigated through functions. In this lesson, we covered some important concepts about functions. A function is a reusable block of code that groups together a sequence of statements to perform a specific task. A function declaration. So this was like the long form of doing it, where you actually state the word function. A parameter is a named variable inside a function's block, which will be assigned the value of the argument passed in when the function is invoked. That's very concise. And yes, so parameters, arguments, right? So you declare parameters and then you pass through arguments. So to call a function in your code, you just use its name, its identifier, and those parentheses. ES6 introduces new ways of handling arbitrary parameters through default parameters, which allows us to assign a default value to a parameter in case no argument is passed to the function. To return a value from a function, we use the return statement so that if you're console logging or basically doing anything else where you want to see inside of the function, not only have it calculate, but have it return a value, then you use the return function or return statement. To define a function using function expressions, this is where you sort of flip it, where you put the variable part of it first, constant, you declare the identifier, and then do like the anonymous function. This again is like long form. To define a function using arrow function notation, this is the shorthand version of that example above. And then function definition can be made concise using concise arrow notation. And this is only true if you have if you only have one parameter or no parameters, and then you only have one operation happening. That can save you some time if it's just the simplest kind of function. It's good to be aware of the differences between function expressions, arrow functions, and function declarations. As you program more in JavaScript, you'll see a wide variety of how these function types are used. All right, what's next? Start next project. Okay, still got a half an hour left in the stream, so we're gonna see if we can work our way through this. Console log. Hi. Rock, paper, scissors. Rock, paper, scissors is a classic two-player game. Each player chooses either rock, paper, or scissors. The items are compared, and whichever player chooses the more powerful item wins. Everyone knows how rock, paper, scissors works. Let's get into the code. So what we need is to be able to get the user's choice, get the computer's choice, and compare the two choices and determine a winner. And then we also want to see what the results were. So we want to start the program and display the results. So the user should be able to choose rock, paper, or scissors when the game starts. So using constant and arrow function syntax, create a function named getUserChoice that takes a single parameter of user input. Okay, so let's do constant getUserChoice. So this will be a single parameter. We're going to go ahead and see if we can do our concise body function because it's so simple. So single parameter of user input. And for now, we don't know what's beyond this, like what's actually happening with that input, but we can put an arrow function and then just nothing at the end for now. We're not sure what's going to be added. So since a user can pass in a parameter, such as rock, or rock with different capitalizations, begin utilizing JavaScript's toLowercase function to make the user input all lowercase. You can use code like this: user input equals user input toLowercase. So that's what we'll put on the right side of our arrow function. User input equals, and they have user input dot toLowercase. Okay, go ahead and make it nice and neat, right? And then if you run that code, it's just going to say hi. Most of what we're doing will be in the background until we actually console log the end. When getting the user's choice, you should also check to make sure that the user typed in a valid choice, rock, paper, or scissors. Inside getUserChoice, write an if-else statement that makes sure the user input is either one of those choices. If it does, then return the user input. If not, use console log to print an error message. So if they try to use Dynamite or Spock, it will not work. So let's do the if statement here. If user input, so we need, let's see, we need OR, right? We need our OR operator. So let's use user input is equal to rock, the string of rock. After this, we need our two pipes, shift backslash, our two pipes for the OR operator. User input is equal to scissors, or I guess paper, paper, and then again, two pipes, and then lastly, user input of scissors. Okay, so once it checks all of that, then the code will run. So return user input. Yes, so it'll check to see if any of those options are true, and then we will return the user input. And then if not, we'll create an else statement, and we'll just go ahead and console log a statement saying, you know, please choose a valid choice. Maybe like say, please enter rock, right? So rock, paper, scissors, or I'll just put this, please play the game correctly. Or just like, no cheating. No cheating. There we go. Okay, so now if we try to put in something for user input, and it's not one of these choices, then it will come back with this message. Test the function by calling it with a valid and invalid input. All right, so we're gonna call it down here. getUserChoice. And inside parentheses, I'm gonna go ahead and do a correct one first, so do rock, right? Oh, let's see, scissors, user input is not defined. User input equals rock, user input equals paper, user input equals that. Inside, oh, that's, okay, see, good teaching moment. This code block of the conditional, the if, it's outside of the function. So what we're gonna have to do is, let's see, so with the arrow function notation, we're gonna have to add curly braces in, and then move this into a code block and include the if, right? So then let's just tab this over to make it a little more readable, yeah. And then add a second curly brace at the bottom. This curly brace is containing the if statement. And what happened here? Oh, if, there we go. Yeah. Okay, so now that should be better. It looks a little bit sloppy because I wasn't tabbing over on these, but let's see about this now. Hi, okay, cool. Now no error message shows up because what was happening before was that the user input variable, it was locked within the function. It wasn't a global variable, so when it looked for it, it couldn't find anything since it was hidden within that function. Now, since we moved it inside of the function, it can see whatever is in the function. Okay. So we've got that. We've got get user choice rock. And we actually want to console log this, right? You can delete this when you know your function works. So let's go ahead and console log the get user choice. And yeah, there we go. So we inputted rock. It says, first of all, hi, and then rock. I'll go ahead and add something up here, like, hi, let's play, oh, that is right. Okay, we went over this last time, but not this time. So we need a backslash apostrophe. Whenever we're adding apostrophes within a string, we need to put a backslash apostrophe so that it will know that that's not the end of the string with the single quotation. So let's play rock, paper, scissors, right? So the computer is inviting you to play a game. Close that string off. Hi, let's play rock, paper, scissors. And then so you input rock. Let's see if we can change this to be like, you know, Spock. So then it says no cheating, but then it also says undefined. So what's going on here is that for any value that's not rock, paper, scissors, it's console logging no cheating. But then since we put console log down here, it's going to then console log what's like what the value is of Spock, like what that is, and it's undefined because there isn't a result that returns anything for Spock, so it's just going to be undefined. So instead, let's delete this. Let's get rid of our console log at the bottom, and instead add it to the return. So add it as a console log of the user input, and this way, when you put in a value that isn't correct, it'll just say no cheating, and it won't try to duplicate what it's saying and then find that it's undefined. So then if we switch this back to rock, and it will be rock. Okay, so that's good. That is working. Now we need to have the computer make a choice. So create a new function and named getComputerChoice with no parameters. Inside its block, utilize mathRandom and mathFloor to get a whole number between 0 and 2. Then, depending on the number, return either rock, paper, or scissors. All right. So get user choice first. Let's go ahead and do it where we declare it as a variable. I guess, yeah, it can be constant because it's only deciding once. It's not going to be changing. Constant, we need get computer choice. Get computer choice. And then set this equal to math.floor. Oh, I see. So this needs to be, I don't know that we need a parameter with no parameters. Okay, yeah, so with our arrow functions, if there are no parameters, we just need that empty set of parentheses and then the fat arrow, so equal sign greater than. And then inside the code block, we're going to say math.floor and then math.random. And then this is going to be multiplied by 2. So math.random finds a value between 0 and 1. And so then this result we want multiplied by 2 to create 3 different choices after it runs through the math.floor, which basically just truncates the decimal value of the number to give us an integer. So math.floor.math.random, and then I think, do we need to return this? Or I think it's fine if we just keep it like that inside of the function, because then, let's see, wait, how would we decide, utilize that to get a whole number, then depending on the number. So we need to set that as a variable, don't we? Yeah, okay, so this actually needs to be a variable, I believe, but they don't quite say that. So I'm just going to put in like choice, right? So let choice equal this. Oh, that's interesting. What's going on with that? Can we not? Yeah, that should be fine. Okay, so let choice equal this. Then I'll do a, let's see, we want to do a switch. Let's go ahead and practice the switch keyword. Switch. This one was, we need to have a choice, right? So choice, basically like an if statement. The conditional is evaluating what's inside of the parentheses, and then we put in case to say if choice equals choice is equal to 1, but I don't think we need to even put choice is equal to 1. We can just put 1 or 0 as our first. If case is 0, then return, and then we want to return rock, and then remember to put in the break lines at the bottom of your switch cases. Then once again, and if you haven't you don't know how to do this, we covered it in the last episode. It should be still on Twitch for you to view in the library, but for now I'll just go through this quickly so we can play our little rock paper scissors game. Return scissors as, or paper as the second choice. Break. But basically the break is being used kind of like return. Actually, I don't know that you need, do you even need the break? I don't know that you would need the break in this case, no pun intended, because you're doing returns, and returns basically act the same. In fact, I don't know if this is even going to work at all. I've never tried return keywords with the switch keyword. So we'll see. This is an experiment. Case 2. Oh, I'm not doing the correct notation. This needs to be a colon instead of a semicolon. So after the case, it's a colon, and then after whatever you're running, if the case is true, then it's a semicolon, and then the break also has a semicolon. So return scissors, and then break. Okay, so let's see if this throws an error right away. I'm not sure. Okay, seems to be fine with that. We'll see in the next step if it actually is able to call that. Okay, so get computer choice, right? We need get computer choice. Get computer choice. And then we also want to console log that choice. There is a way, let's see. I guess outside of the switch, you might be able to console log choice. I'm not sure if that will work. Yeah. Oh, do we have to return the console log of choice? No. So this is the sort of thing where it's like, I want to console log what's inside of here, right? But the variable is being declared within a function. So return to console log user input. Just looking back to see how we did it up here. So we returned the console log of user input, which was a variable or a parameter that we defined. Interesting. So I would, they had us put no parameters here, I would actually make this parameter choice, right? So let's see if we make this a parameter. Choice has already been declared, right? Yeah. That gets a little more complicated, because then you're going to have to make a variable that references the parameter that does the math calculation. We'll just keep it simple and tackle that another day. We're going to console log the computer choice so we can see if all of that is working just fine. And it is not. So let's see. Choice has already been. Oh, I did it again. Yeah. Let's get rid of that. There we go. Okay. So yeah. So that way we console log our computer choice of paper. And now if we run it again, it should be a different number or a different option. There we go. It's concerned there for a moment. It did paper 3 times in a row. Rock, paper, rock, 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 rock. Okay. Looking good so far. Now it's time to determine a winner. Create a function named determine winner that takes 2 parameters, named user choice and computer choice. Okay, so then I guess, yeah, this can happen before everything is logged to the console. This function will compare the 2 choices played and then return if the human player won, lost, or tied. Let's deal with the tie condition first. Within the determine winner function, write an if statement that checks if the user choice parameter equals the computer choice. If so, return a string that the game was a tie. Okay, so we want to create a function named determine winner. So constant determine winner equals, and this will have 2 parameters of user choice and computer choice. And then inside of the block, we will compare these values. So if the user choice is equal to the computer choice, then console log. So we want to console log it, but not yet. All we need to do right now is return the value of the result. So return this statement, and then at the end, in the last step, we'll console log whatever the evaluation was, and then it'll take one of those strings. But for now, we're just going to say return it's a tie. And remember \apostrophe to add in an apostrophe within a string. It's a tie. Okay, and then the else if, we'll go ahead and put that because we know we're gonna put an else if in. If the game is not a tie, you'll need to determine a winner. Begin by writing an if statement that checks if the user choice is rock. Inside the if statements block, write another if-else statement. If the inner is if-else, should check if the computer choice is paper. If so, return a message that the computer won. If not, return a message that the user won. Okay, so instead, so we're not doing an else if. Begin by writing a statement that checks if user choice is rock. Or another if-else statement. If the computer choice is paper. Okay, so they want us to do it in separate steps, which is fine. We'll do that. I don't know if it would be, I mean, I'm sure it's possible to combine it into all one conditional. Go ahead and give us some space here because it's going to be a little bit more lengthy. So if the user choice, yeah, so it has to determine like each possible outcome. So like rock could then have rock, paper, scissors, paper could have rock, paper, scissors, scissors could have rock, paper, scissors. So all of those options. So yeah, all those nine options. So user choice equals rock is equal to rock. Then Then we write an if-else statement. Okay, and then it's going to check to see if the computer choice is paper. So then we say if computer choice is paper is equal to paper. Return a message that the computer won. So then return a string of computer wins. And then else return a string of you win. Okay. Oh yeah, it's not gonna like what we're doing so far. I saved it just out of a reflex, but anyway, it doesn't know that. Or wait a second, did I add an extra user choice, computer choice? What's this? If else, that does have a pair. Let's see, unexpected token of a curly brace. All right, we'll handle that in a minute. Apparently there's an error with my syntax up above, but we'll deal with that in a moment. I'm not sure why it doesn't want that. User choice, computer choice. Oh, that's right. I didn't put the arrow. We need our fat arrow. There we go. And now it should be okay. Yeah. User choice is not defined. So wait, we need all of this also to be in that same function. So it is within one step. It's just that they have, yeah. Okay. There's multiple conditionals, but it's all in one function. So then, if I can anticipate, right, user choice, if this is equal to paper, then we want to check to see if the computer choice is equal to scissors. If computer choice is equal to scissors, then return a message that the computer won. Computer wins. And then else, return a statement that you win. You win. And then thirdly, we'll put in another if statement, checking to see if the user choice equals scissors, and then check to see if the computer choice equals rock. Equals rock. And then so if it is, then return computer wins. And then else, return you win, right? Okay, so far so good. There were no errors that showed up. So now we just need to log what we coded here. So let's see. Yep, so the next step was paper, the next step was scissors, etc. Write the logic that will return a winner. Don't forget to test your function. So we want to be able to test it. So we're just going to call it down here. I guess, let's remove all of this space so we can see the function call. So we're going to call the get user choice, call the computer choice so that it will log that to the console. And then I think since this is, yeah, we're just going to call the determine winner function. I think we need a console log with it. Console log determine winner. And see, there we go, it's a tie. Let's see what it's doing. It's a tie. It's a tie. So it's always a tie. So something's up here. So no matter if yeah, if the computer wins or anything like that, it's always a tie. So let's see. I had a feeling that would be the case just because, like, yeah, it felt like something was, we were contradicting something writing this. So let's go back up to that step and see where we got off. So if the user choice is equal to computer choice, right, return, it's a tie. So, determine winner. Oh, we need parameters, right? Like, so yeah, that's interesting. So I don't think they told us that part. Let's see, create a function named playGame. Inside the playGame function, create a variable named user choice and set it equal to the result of get user choice. Passing in either rock, paper, or scissors as an argument. Create another variable named computer choice and set it equal to the result of calling get computer choice. Under both of these variables, use console log to print them to the console. Okay, so I think it will be okay if we do the rest of this here. So we need to create another function. PlayGame. Oh, I'm skipping ahead here. We need to declare it first. Constant playGame. So this will equal with the parameters of, let's see, inside this, create a variable named user choice. Get computer choice, get user choice, set it equal to the result of get computer choice. So okay, so basically they just want it to be, they want it to be a function without parameters, even though I think you could do it that way too, but we're going to do it this way. We're going to declare a variable named user choice. But isn't that what we did up here? So how is that get user choice? Under both of these variables, use console log to print them to the console. The result of calling get user choice. Okay, we'll trust the process for now. I think, yeah, in the next couple of steps there might be, yeah, the determination of who wins is coming up next. So I'll try to run through all this and then deal with the errors. We'll see how far we can get. So constant, or I guess let, right? Let user choice, and then set it equal to get user choice. And then let computer choice, set it equal to get computer choice. This is the example of the helper functions that we were seeing earlier. Under both of these variables, use the console log to print them to the console. Okay, so then console log. I'm sort of confused because we already did this bit earlier, yeah? Like it's already declaring. Oh, because it doesn't want us to do, yeah, I'm going to comment out what we did at the bottom here. Just comment that out for now. It's basically taking these steps, these two console logs, and putting them inside of this function. So console log user choice. And then console log computer choice. Of course, that didn't do anything. Because we have to declare, or we have to call the function. Yeah, so the phone number is set up. We haven't called it yet though. So let's call that phone number. So when we inside the playGame function call the determined winner function, pass in user choice and computer choice variables as its parameters. So we need the determine winner, user choice, See, and this is where it all ties together. So user choice and computer choice. So these two things, right, are then calling back to the get user and get computer choice, which we coded up here. So, and then those results, the values from those, or the strings from those, are going to be passed into the determine winner function, and then this code should work properly and not say that it's a tie every single time. Before, it was just because that the user choice and computer choice were both undefined, so then it was automatically a tie because they were always undefined. Okay, so determine winner, user choice, computer choice. Make sure to put this function call inside of the console log statement so that you can see the result. Then to start the game, call the play game function on the last line of your program. So let's be brave. Let's delete the console logs that we had before. Let's go ahead and put this inside of a console log. Again, Control Shift and arrow keys for a quick selection. Shift and left parenthesis in order to bind it in parentheses. All right, and then at the end, this is the key, play game, and then just have it run. Moment of truth. Okay, so cannot read property, 2 lowercase of undefined at get user choice. Get user choice. User input dot 2 lowercase. This is not what I was expecting. I thought that all of this was all good, but I guess it was never actually running this code, so it didn't see that it was off. Cannot read property 2 lowercase of undefined. So let's go back up to the top. Let's see. Do some backtracking here. So up here we are declaring a user input. This can be any name, or sorry, not name. This is the rock, paper, scissors. So user input, constant arrow function syntax. So if it's a single parameter, it doesn't need parentheses. So we're good on that. The curly braces are there, that's fine. It's just a matter of this, right? So it sees that user input is undefined. Using takes a single parameter. Since the user can pass in a parameter such as rock or rock with different capitalizations to make a user input all lowercase. Okay. And that code is copied exactly, yes. When getting the user's choice, you should also be able to check to see that if it's rock, paper, or scissors. Oh, does this have to be at the bottom of all this? So it looks at it first and then defines it? I mean, I know it's undefined currently. Oh, I see. Hold on. It's down here. So all of this is tied into what the person inputs, and this is actually going to be in user choice, get user choice with a parameter. If you don't put a parameter there, the user input is undefined. So this is the argument we're passing through into the user input parameter. So we need to say rock, right? Voila, sort of. Okay, so no errors, but yeah, so undefined. So it's console logging. What is it doing? Okay, so still got a little bit to work through here. Okay, so rock, it's seeing that's seeing the user choice, seeing the computer choice. Let's backtrack here. So console log user choice. If we get rid of these, right, these should disappear, but I think it's not doing that. I think it's the determine winner is the problem. So let's eliminate determine winner and see what happens. That's still putting in an undefined. Do we have an extra? We might have an extra console log somewhere. Yeah, like, no, because we want that to return. Oh, yeah, it is probably this then, huh? There we go. So we had a console log when it was returning the user input, and then that kind of screwed up the rest of it. So rock, it's a tie. So far, that's good. Let's see if everything is a tie. Still tie. Hey, there we go. It works. So rock. So the user choice is rock. Computer choice is paper. Computer wins. In fact, I'm going to go back up and add in so that we can see return. We're going to go ahead and interpolate if we can with this variable. We're going to say u, right? So like, or player, let's say player, right? So the player input will be this. This is going to be contained within curly braces and the $sign within the backticks. And then there you have the player come up so you can see who chose what. And then the computer choice, let's see, return. I guess we would need to do that for all of these. Yeah, so just do like, let's do it with concatenation. So computer, colon, and then plus that, and then just copy this down to the other options. There we go. And then, oh, and add a space after the choices, or before the choices rather. There we go. Hold on. Undefined, no! Okay, so it might be the... Wait, when did it do that before? Yeah, so I might have to... So it's not returning the user input then. So I need two lines then, right? I need to return the user input as a variable, and then I can return it with a string, right? Yeah, there we go. But then it doesn't, then it ends. And it ends. What I'm trying to do is make it so that you can see who chose what. So let's try, instead of that, let's go back and see if this works without interpolation. If this is just like something that you can't do with that and you need to have a concatenated string. Plus, and then user input, is that? No, you need to have it be just this, right? Player rock, undefined. It's still undefined. Okay. So let's see what's happening down below then. Right. No cheating. Let's see. Get user choice, get computer choice. Console log the user choice. And so then user choice is going to be the result of get user choice with rock, which is going to put rock into here. It's going to put that to lowercase, and then it's going to see that it's rock, and then return the user input. Then when there's the determination of who wins, the user choice will equal, or if it's equal to, that's working just fine until we see undefined. So user choice, determine winner. Just trying to link back, like see where all the control flow connections are. So determine winner, user choice, computer choice. User choice is the result of get user choice of rock, which is the result of this, which is returning the user input, which is rock. If user choice equals rock. Oh, I see. I see. So it's not defining it, because what we did here, the user choice has to equal the string, this string, right? And then it returns you win. So return user input. I wish there was a way where you could do it. You could return something, but then return a different data type. So, like return a variable, but then return also a data type. Instead of like reworking the code, reworking all the conditionals down here, I don't know how we would change that without letting the bottom be undefined. But for now, it's still pretty self-explanatory because your choice is of the rock, then it shows what the computer chose, and then it tells you that you won. Yeah, because there wouldn't be a way if we return user input like plus something. No, but this has to equal a specific string in order for the conditionals to work. Has to equal rock, has to equal paper, has to equal scissors. It's tie. It's a user choice. So the way that we're doing it with a computer, though, is just like returning computer plus rock. And then, so it doesn't seem to have a problem with the computer choice changing. Yeah. So the computer choice, or I guess it does, because it still returns as undefined. If this, then you win. Yeah, so right now, So I don't think we can do it in these steps. I think we have to do it at the end. We have to add in those words at the end. And this is something, it's not part of the instructions. I'm just trying to puzzle out this part of it. Make it a little more user-friendly, right? Rock, whoops. Got a space in rock there. Rock, it's a tie. So that's returned, console log. Oh, this is how we do it. Right down, so everything is set up to where at the bottom we can add in a string and concatenate that with the variable. So this is going to be u, right? U colon plus a user choice. This one is going to be computer colon plus there we go. Yeah. And then we'll want a space in between there. There we go. Yeah. Yeah, cool. Yeah, because everything was tied together with like the results of what the user choice like literally was, you know, had to be a specific string or else, right? So once we evaluated all of that data and got the results, then we could change it at the bottom and make it a lot simpler, just in one console log, adding a string to the result of the variables. And once again, like that funnel, like we were talking about earlier, like the funnel started with us like, okay, determining all the probabilities or the possibilities. And then it was like, okay, let's make it into one, like the thinner part of the funnel was, let's make it into 3 console logs all together. And then at the very bottom, the very tip of the funnel, the thinnest part is just play game. And that way you can just type in play game, one command runs all of the code. Much like hitting like enter on a video game or something. All right, so that's good. We could run it a few times, see that the it's a tie is working for when it's, wow, it's been rocked 5 times. Computer wins. Yeah, we really like choosing rock. But yeah, computer wins. Let's see if the computer loses or if you win. Can we have a you win? Will the computer ever choose scissors? I don't know. I don't think the computer ever chooses scissors. Okay, we're not quite done yet. Not quite done. I think we have to multiply the math by 3 instead, right? Right. There we go. Scissors. Yeah, because by 2, if you multiply it by 2, The highest it could be would be 2, but that would only happen like extremely rarely. Yeah, because if math random was 1, oh, that's interesting. So if math random was 1, right? Because it picks a number between 0 and 1. Then you multiply by 2, it would be 2. But then math.floor takes it and says, okay, the only way it can be 2 is if it's exactly 2. So you would only get scissors like once in a billion tries, right? Or whatever. But with 3, you get scissors a lot more often. But there is that, you know, once in a million possibility of getting a 3 and then not having it choose anything, right? And it just being undefined. Unless math.random really is truly between 0 and 1 and it doesn't include 0 and 1. But I don't know how that works specifically. Anyway, okay, so the last step, make this game better by adding a secret cheat code. If a user types in bomb as their choice, then make sure they win no matter what. Okay. Secret cheat code. So type in, yeah, we need an else if, right? So we need an else if. Else if. And then have it be user input equals bomb. User input equals bomb. Then, so how would we do this? How would we say, how would we make it a guaranteed victory? Oh, I know, yeah. I know. So just return user input, right? So this doesn't actually have to be an else if statement. It's just going to return the user input if it's also bomb. So we just need to add it as one of the options here in our or statement. So or user input is equal to bomb. Okay. And let's make that dynamite. And return the user input. So now we have bomb as a possible option. So we can add a conditional here. So if user choice is equal to bomb, then we do no matter what. So this doesn't, we don't have to evaluate the computer's choice because this is just like no matter what, you win. Yeah, so just say return you win. And then so it will do that no matter what. And as you can see, quick note, I only use a semicolon up here. I didn't use a semicolon for any of the return statements. You don't need them. You can put them if you want, just to have good practice, good habits, but do not need them for the return statements. All right, so let's see if we can enter in bomb, and we'll go ahead and reload this page and enter in bomb. Okay, so a couple things happened. So U is undefined. So user input. Oh, whoops. I forgot I changed it to dynamite. So we need dynamite. Dynamite. But then the win condition is undefined. Right, because I put bomb there too. I changed it and then forgot that I changed it. So let's do dynamite. Dynamite. There we go. So no matter what the computer changes with dynamite, you will always win. Or let's just say, like, you know, you yeah, so computer has detonated. Computer has detonated. Sweet. Yeah, and then we could try, you know, scissors, what have you. Should still work the same. Sweet. Well, that is rock, paper, scissors on CodeCademy, using our function. So already, you know, we have what, 64 lines of code that's decently concise. So already we have a lot of possibilities with our functionality, pun intended. So we know functions now, we know conditionals and the basics. So next time we will go over the sleep debt calculator. But for now, I will say good day to you all. Thank you for joining. Thank you for being active in the chat and following along as I learn how to create video games from the ground up. We will do this again, hopefully tomorrow. And until that time, I'll see you. Have a good one. Peace.